In this video, let's try to understand how can we actually implement the get operation on a singly linked list. So the main purpose of get functionality on a singly linked list is to retrieve the node that is available at a specific index. So as part of this get functionality implementation, what exactly we request from the user is basically the index. Index is nothing but the position at which the node is requested by the user. So first, let's try to understand how the indexes actually work in the case of singly linked list. So it is not a complicated thing. If you happen to know arrays concept, right? We know in the arrays the index starts from 0 and ends at the length of the array minus 1. Similarly, in the case of singly linked list also, the index will start from 0 and ends at length of the linked list minus 1. So if I have to add the indexes to the nodes that we have inside the singly linked list, right? Let's try to do it on a sample linked list that we can see here. So here we have a singly linked list containing 6 values in it. So obviously the starting index will be 0 and the ending index will be length of the linked list minus 1, that is 5. So here the very first node, that is 10, will be available at index 0. Similarly, the node with the value code will be available at index 1. Similarly, the node with the value true we have at index 2. Similarly, all other nodes also we can give the index value. So as part of the get operation, if the user passes a certain index, right, we have to return the node that is available at that particular index. So we are expecting the index value also from the user from 0 till the length of the linked list minus 1 as part of the argument. So that is how we actually represent the indexes in the case of singly linked list as well. Now let's go ahead and let's try to understand what all are the different cases that could possibly come when we try to implement the get functionality. So let's just try to understand the different cases. Obviously here we are taking the index as an argument from the user, right? So user might not be aware of the length of the linked list and can give the index that is beyond the maximum possible index or any negative value as well. So we have to handle those cases as well. So as part of the first case, let's try to handle invalid indexes. So the minimum possible index is 0 and the maximum possible index will be length of the linked list minus 1. So any negative values or any values beyond length of the linked list minus 1 are actually invalid indexes because the nodes that are available are at index 0 till the length of the linked list minus 1 only. So if any other value comes, first what we have to do is we have to simply return null or none based on our choice of programming language. If you are using Java or JavaScript, you will simply return null. If you are using Python based programming language, you will simply return none in that case. Because user has passed some invalid index, that could be negative index or it could be the index that is not in the range of whatever the indexes that we have in the singly linked list. That is the case where we handle the invalid indexes. If the second case is actually the valid indexes given by the user. So if the user has actually given the valid index, right? So our job is to start at the head node and we have to go to the node that is given by the user at that particular index and we have to return the entire node here. Okay, we are not simply returning the value we have in the node, rather we are returning the complete node. Okay, why? Because we can reuse this get functionality in the future operations such as set, insert, delete, and all these functionalities we can reuse this get functionality. That's why we make sure that we are returning the entire node object but not the value. Okay, so how will we actually do that, right? So we will, let's assume that the index that user has given is, let's say, 3. So that means that my program should return the node that is available at index 3. That means I should return the node test as a output. So what exactly I will do is I will start traversing the linked list at the head node, because in the single linked list that I'm implementing, I have the access to the head node, I have the access to the tail node, I have access to the length of the linked list. Now Since I have the head node, I can start traversing at head node. From head, I can go to the next node, right? Because each and every node has the reference of the next node. That means if I go to the next node, I will be at index 1, which is not the index that user has requested. So on index 1, I will again read the next node. I will go on to the index true, right? Now this is at index 2. That is not the index that user has requested. User has requested the node at index 3. So again, from the next that we have on the node true, I will go on to the node with the value test. Now my index is 3. So I can simply return the node with the value test as a output here. Okay, so for going to the index that is available at a given index, we will simply be running a loop. How will I exactly run the loop? That I will show you when I write the pseudocode as well as the programmatic implementation. But this is how, this is the overview of how we can implement the get functionality based on the index that user is passing. Okay, now that we have understood the different scenarios that could arise while implementing the get functionality, right? Let's try to write the pseudo code for implementing the get functionality as well. So here what we will do, we will simply write a function called get, and here we will be taking the index from the user. So when we discuss the algorithm, right, what exactly we discussed, there will be two checks. The first check is to check if index is invalid. So how will we check if the index is invalid? Internally in the singly linked list representation, we are keeping track of the length of the linked list. That means we know the minimum range is 0 and the maximum range is length minus 1. If at all, if the user is, whatever the index that user is passing, if it is less than 0 or greater than or equal to the length, that means that is a invalid index. Based on that invalid index, if the user is giving, right, obviously we will not have the node at that particular index, so we will simply return null or none based on our programmatic implementation. If we are using Python, we will simply return null, none. If we use JavaScript or Java based representation, we will simply return null here. Okay, so this is the case if the index is invalid. Okay, as part of the next scenario, we have to handle the valid indexes. So anything that is not falling onto above range, that is if the index is falling in the range of 0 till the length of the linked list minus 1, that user has given a valid index. Now here what we have to do is, I will simply define a variable called current node, and I have the access to the head node, right? I will simply assign head node to it. Similarly, I will define one variable like counter and I will initialize it with 0, because right now the node that I'm processing is at the very first node, right? Let's assume that I have a singly linked list containing, let's say, 4 values. Let's say 10 code, let's say true and false. The index that user has given is 3. Let's assume 0, 1, 2, 3. This is the head node, this is the tail node. Since I am starting at the head node, right, the counter I am initializing it with 0. Now what I will do is, I will simply run a loop while this counter is not equal to the index that user has given. That means that I am not at the index that user has passed. Inside this while loop, what we can do, we can simply, we have the node reference. On the node we have the next available, right? So we will simply update current node variable with current node dot next. In that way we are simply moving on to the next nodes, and since we are moving on to the next node, the counter should be incremented by 1. So counter should be counter plus 1. Once we go to the index that is given by the user, right, the current node will be available at that index, and the current node variable whatever we are using will be having the reference of the node that is available at that particular index. So we will simply break out of this loop. In the end we will simply return the current node. Okay, this is how we exactly write the pseudocode for implementing the get functionality on a singly linked list. In the next video, let's go ahead and let's try to write the programmatic implementation of it as well. So now inside the singly linked list class that we have written, I will write a function called get, and it will basically take the index from the user. Basically, it will need to return the node that is present at this particular index. And we already understood that this index follows the similar pattern of the indexes that we have in the array, right? In array, the index start from 0 and ends at length of the array -1. Similarly, in the case of singly linked list also, the index starts from 0 and ends at the length of the singly linked list -1. So there could be two scenarios, right? Whatever the user he or she is passing, whatever the index that is passed by the user could be a valid one or could be an invalid one. So to eliminate all the invalid ones, first what I will do is whatever the index that user has passed, I will check if it is less than 0 or if it is greater than or equal to the length of the singly linked list. That means this dot length we are maintaining anyway. If it is same as length, it is not possible as well. So in these two cases, what I will do, I'll simply return null. Okay, I'm eliminating all invalid indexes range here. Okay, if this is not the case, what I will do is I will define a variable called I and I will assign it to 0. I will also define a variable called current node and I will assign it with the head node of the single linked list. Now all we have to do is we will have to go on to the node that is available at this particular index that user has given. To go on to that node, what I will do is I'll simply run a loop as long as this I is not equal to the index that user has passed. I will simply move on to the next node by simply updating the current node to current node dot next. Okay, current node equal to current node dot next, and I'll simply increment the I to I plus 1. Okay, once the value of I matches with the index that user has given, right, this while loop will break. That means it will come out of this loop. Whatever the value we have in the current node, right, that will be the node available at the index that user has passed. So we will simply return current node. Okay, this is how we basically implement the get functionalities. First, two scenarios: exclude all the non-valid indexes and run a loop and go on to the node that is available at that particular index and return that specific node. Okay, now let's try to execute it and see if it is working as per our requirement. Let me just uncomment these 4 values and let me just comment out these traverse functions also, because we will not be needing this, and this log head and tail and all those things also we can comment out because we are not doing anything in the get function with respect to head and tail updation. So all I will do is I'll simply call the get function. I'll pass the index. Possible range of index is from 0 till length of the single linked list -1. Since we have the 4 values, right, let me pass 0 first and let me just take the result into some const result and let me just log it. Console dot log of result. Okay, if I just execute this, it should basically get the node at index 0. That means the first node, that is the node with the value 10. I simply execute it, node singly linked list dot js. If you observe here, the get function is basically returning the entire node. If you want to print the value, you can simply do result dot value, which will only print the value. Okay, if I execute it, okay, you are seeing the value of 10. Similarly, if I pass any valid index that is from 0 till length of single linked list -1, here we have 4 values, right? So the largest possible index is 3. So if I execute it, I should basically get 10.134 here, which we have got. If we pass any valid value also, we should basically get that value here at the index to 0, 1, 2, which is true. So we've got true here. If we pass any negative or the indexes which are more than the length of the single linked list, we should basically get null here. Okay, we are getting exception because we are trying to read the dot value from the null, which is not possible. So we'll simply remove it and we'll simply execute it. Okay, so we've got null. If I pass any positive value which is greater than or equal to length also, we should basically see the same thing. Okay, we have got the null value here. Okay, this is how we basically implement the get operation on a singly linked list using JavaScript implementation. Okay, and the time complexity and space complexity involved in the implementation process, and both these also let's just try to understand in terms of best case scenario as well as in the worst case scenario. So when will the best case scenario of get operation will actually occur? Whenever the index that user is passing, if it is equal to 0. That means that let's assume that our singly linked list contains some number of nodes, right? And we have the head node and we have the tail node. When the user passes an index 0, whatever the iteration logic that we are executing for reaching the node at that particular index, right, that will not even get executed. We will simply return the current node immediately. So obviously, since we are not running the loop, the time complexity will be order of 1 in the best case scenario that occurs when the index that is given by the user is 0. Now, when will the worst case scenario will actually appear, right? Let's assume that the singly linked list on which we are trying to perform the get operation has n number of nodes. So the worst case scenario will actually appear when we are trying to read the or get the value that is available at the very last index. That is, the index that user passed is equal to length of the linked list minus 1. In that case, we will have to start traversing at the head node, and one by one node using the next references we have to reach the very last node. That's why whatever the iteration logic that we are writing, right, it will get executed for n number of times. As a result, the worst case time complexity will be order of n in worst case scenario where the index given by the user is n minus 1, and in the best case scenario the index that is given by the user is 0 and the loop will not get executed and the time complexity will be order of 1. Now that is in terms of time complexity. Now let's just try to understand in terms of space complexity. Be it best case or worst case, what exactly we are doing inside, even if we execute the iteration logic that we are writing for getting the node, right, there we have basically defined two variables. One is to keep track of current node that we are processing, and the other is a variable called counter which keeps count of how many number of times we are iterated. Basically it keeps track of if the index is matching with the index that user has passed, right? And we know these two variables will take constant amount of memory. So obviously, even if it is the best case or worst case, same variables will be reused. As a result, be it best case scenario or be it worst case scenario, the space complexity will be order of 1 only. Why? Because we are simply using the same current node and counter variables for keeping track of the next node that we are processing and the index that we are currently processing. Okay, so that is the way we calculate the time complexity and space complexity for get operation on a singly linked list. Okay, in the next video we will see how can we reuse this get functionality for implementing the set functionality on a singly linked list. Okay, I'll see you there.